And so welcome to this training. We are going to talk about containerized software on the Open Science Pool. And let's see here. There we go. All right. So let's start with a few introductions. On this call, it's me and Rachel. Andrew should have his picture here. He's also a facilitator. And so we are the team behind tickets. So when you email support, or if you go to office hours, this is the team that you will you'll meet with. We're a distributed team. We're in different universities, different locations, but together we make up the support team. This is interactive training. We are encouraging you to ask questions. So just either unmute yourself and ask a question, or you can also do a chat. I can see the chat while I'm presenting. So chat is also a fine method of doing this. I'm going to do this here. Okay, so I can see everybody. Okay, and you can do raise your hand if you want to. Just the standard Zoom stuff. After the training, we're going to make the slides available, and if it turns out well, the video as well. The agenda for today is first we're going to start talking about why we are so excited about containers. We're going to talk about finding existing ones, building your own, testing containers, and then using those containers in your jobs. So one of the reasons why we're so interested about containers is the distributed nature of OSG. So the dots here are sites, like these are places where your job could land. And what you have to realize with all those dots that they are not owned by OSG, right? Like this is not our resources. We are just borrowing them for your benefit for your jobs. And so what you have to realize that each one of these little green dots have system admin, local system admin that managing that resource. They have local policies, right? Like different institutions will have different policies over resources. They will have different ideas of what should be installed by default on these machines, like what operating system there should be. So looking at all this, you're thinking, okay, this must be a mess. This is really, could be anything. Kind of true, but really what happens is that the high throughput community and HPC community are, have a small set of softwares that we like. So for example, operating systems, 9 times out of 10, it's some kind of RHEL-based system, and so you could write code specific to RHEL and say it's a good chance that I will land on one of those machines. But what we can do, what containers can do, is to provide a kind of a protection against these problems. So, for example, like that inconsistent environment at those different sites, if we have the container and we run the job in the same container every time, now we do have a consistent environment. Doesn't matter what the site is doing, we bring the environment, we control that environment, and thus get a really consistent one. The other thing I'm going to talk about, and I have more slides about this, it's a complete environment, right? It's not just your code, but it's also everything that your code depends on. And it's a reproducible environment, right? This is software defined. We have recipes for create these containers. So we can, move back in time, for example, if we want to rerun a set of jobs under the same environment that we had last year, we can, because we still have the same container, we still have the recipe for that container. Whereas if you did that on just straight on the hardware on OSG, maybe a site has been upgraded, something has changed, right? So let's do an analogy to kind of describe this kind of approach. And So if we start with talking about cooking and cooking at home. So if you cook in your own kitchen, it is basically the same thing as running on your own computer. Right? We know where everything is. We know what we have in the drawers. We know what we don't have. We know where and if there's something that we need, like if we need a new something in our kitchen or a new piece of software, we have full control of making that available and insert it into our environment. The problem here, right, is that we are not cooking in our own kitchen, right? We are going to somebody else's kitchen and we are cooking there. And that's the same idea of going to somebody else's computer and running the software. So the same problem, right? We don't know what they have. We don't know what's in that kitchen. So if we have to open drawers and look around and see what's there, maybe they still don't have it. Maybe we can't even cook because there's something that's fundamental that's missing. So same thing with software here, right? If we depend on R, is that installed on one of those sites? I don't know, right? And if it's not installed, what do you do about it? Can you maybe use something else, or can you bring it in? And are you even allowed to do any changes, right? So that there's a lot of flexibility that you have to have when you're cooking in somebody else's kitchen or you're running on somebody else's computer. Now, the solution, and this is pre-containers we're talking here, but the solution is to think like a backpacker, right? You bring what you need and just assume that there's nothing there, right? So you bring your code, you bring your usually it's a compile executable, right? And you bring it there, and then you should have everything that you need. And there's always a line that you have to draw, because you have some assumptions, right? You have an assumption that there's a base operating system on that machine. You have the assumption that it's running Linux, maybe don't care what version, but you are very flexible because you're bringing your own stuff. The containers take that to the extreme, right? We're bringing everything. So in this case, we're bringing a whole caravan that has a little portable kitchen in it, and it has all the stuff that we packed into this caravan, because maybe we wanted to cook, and maybe we would need something, and so we basically overdoing it, right? We're bringing everything, but it's still a good analogy, because it's the same thing with containers, that we would bring the container like it's bigger than we need it to be, but it's convenient, right? Just like a caravan would be, and it's complete. And that's a really important point here. So some of the motivations, why are we, as I said, so excited about containers? We talked about this already. Consistent environment. What you don't know is that if you have run on the OSPool like last 3-4 years, and you don't specify a container, there's a really good chance your job ran in a container anyways. We are running default containers when users don't even ask for them. And that comes back to those green dots, trying to provide a consistent environment across all the sites, even if the user is not specific about it. And the reason this works well is that the overhead is so low. Right? It's a tiny amount of overhead for us to put the job and run it in a container, versus having trying to work with the user to make the code more portable. The second bullet is a custom software environment, and that's mostly what this training is about, is that we can create our own containers, own images, and package up what we need and make it environment exactly like we want it. So that's a really a big step forward compared to just having portable software. And it's especially obvious when it comes to things like GPUs or Python with like really big software stacks where you have a lot of dependencies, and like packaging everything and having a complete testable environment you don't have to worry about landing on a site and having a small piece missing of that stack. Below the line here are a few kind of infrastructure motivations that we are really good, that we think are really good, from supporting users, right? And so those are process isolation and file isolation. The point here is that if you're running your jobs on a shared infrastructure, and the fact that you get put into one of these containers, and that means that you're in a sandbox and you can't see what other people are doing on that machine. So that means that you can't look and see what else is running from the site itself or from other OSG users. And it's a really convenient way for us to present OSG to sites to say, when we run on your site, the users are sandboxed and they have a limited amount of insight into what the environment is. We're going to talk about a few different container technologies today, and they use different, and we are using a little bit of pieces of each one. So the first one you might hear about is Docker. And this is it's a famous one. It was one of the ones that kind of defined container, or at least popularized containers in the majority of sciences. And the thing with Docker, though, is that it's a system that's mostly targeting on microservices. Like it makes a lot of assumptions about the security model of the machine and what the privileges are. And therefore, it's not used a lot in shared scientific computing systems. You won't really find this on like your campus cluster or anything like that. But it is super convenient because, one, it has a huge catalog of existing containers. And so we can go in, and if you need a specific piece of software, there's a really good chance that somebody has already packaged it up for Docker, and that you can just either take that and run your job directly on that image, or you can take that as a base image, put your stuff on top of it, and then make that your own container. And that's what we're going to do here in a few steps. The other two that we are talking and we're using a lot is Singularity and Apptainer. And they were developed to be used on clusters and other shared systems. The security model is very user-centric, right? So when any user can run a container, it keeps it running as that user, and you have no more privileges in the container than you did on the host that you're executing it on. So it works really well on shared systems. It works really well for when you have, for example, shared mount points and data that sits in that system, because you get the same rights that you had before. The apptainer here is a fork of Singularity. There's some what's it called, politics behind this, but basically Singularity, it was created, it became a little bit more and more commercial, and took a little different path than some of the creators wanted it to, and they forked it off and they created apptainer. So currently apptainer and Singularity is actually very, very similar. You can create images with either one and they will work in either other one. It's not guaranteed that that's going to keep on going, but for now they are direct replacements of each other. And this is the system that we are using on OSG. When we run jobs, they run as Singularity or Apptainer containers. Even if they were defined as Docker container, when we execute them, we're using Singularity. So before we go on, any questions on the background and the motivations here? Okay, well, let's keep going. So the next thing that we want to talk about is is how do you find existing containers? And what we're going to do is, there's a few different ways. So first, there's a set of OSG provided ones. So we have a list of containers that we have created that are, for example, different operating systems, for different languages. There's a MATLAB runtime, for example, that is very good. If you have MATLAB compiled code, we can run it in that runtime. Or there's some project-specific ones. And there's certain tools like FreeSurfer, GrowMax, GrowMax GPU, TensorFlow. So there's a set of containers here that you can use directly in your job. If this is what you need, you can just use one of these. There's a large number of them that get synchronized in. And I'm not going to talk a lot about this, but this is a list of Docker containers that we have made easily available on OSG. There's like hundreds of them, like 400 or 500 of them that's available. So you can look in this list and see. But more importantly is finding stuff in Docker Hub, right? So this is where I said that this Docker Hub has a huge catalog of existing containers. So we can search for something here saying, I want to do bow tie, right? And there's all these people that have made containers. So if you want to use this bow tie tool, well, you can just use one of these containers. And you don't have to build it yourself. And these are also sometimes comes with support, right? So like this one is very popular, for example. There's probably a good chance that there's a whole community that you can go and there's wiki containers, there's all this stuff that comes with the containers, not just like a few bits, right? It's a community that comes with that container. So Docker Hub is awesome finding containers. And we are going to use Docker Hub containers here later on when we create them. But the point is that before you jump in and create your own container, look around, see what's out there, and maybe somebody's already done the hard work for you. So let's say that if you could not find an existing containers, or you have some kind of custom requirement that means that you want to build your own container. So how do you do that? So I will just jump around a little bit. Well, we can start with this. So first, what is a container? Well, it's an image, right? It's a complete OS image in the sense that it has the whole file system. And that file system is looks just like a Linux machine. It has the same structure. However, one of the things that is common and that really want to make sure is where to install the software in this file system. And it's really important that you don't install software to home, root, or serve. And the reason for that is the first one is the container will run as a user different from yours. So if you put stuff in your home directory and then you give that container to a site and then run it, that the home will not be the same. So do not use home for that reason. /root is only available to unprivileged. It's not available to unprivileged users. So if you put stuff as root, you can't access it as a regular user later. And /srv is used for the job's working directory, and it's not appropriate either. So if you need to install something in the container, /opt or user local are good places for it. You can do anywhere except the ones I mentioned here, but opt and user local are very common and kind of conventions that a lot of sysadmins are using. So it's a good choice. We will just jump into the deep end here, and let's talk about how to build an apptainer image. And it has, what we need to do is create an image definition. This file describes like the steps that they're going from one state to a fully complete image. And there's a lot of different sections that you can put into this build definition file. We're just going to talk about a few today. And the first one I want to talk about is post. So there's percentage sign post. And we're also going to just talk about what the preamble up here looks like. So in this case, we say we want to use a Docker image, and then we specify what Docker image. This is what we call a base image, right? This is something that we can, that has a fairly complete OS in it, and we can just build on top of this, right? So in this case, we're saying start with an OSG image based on Ubuntu 20. And we'll run a few system calls first to update it. So we get update that updates the package list. And then we install a few packages that we need. So Python 3 pip, Python 3 numpy. And then last step is that we pip install something from pippy. And the reason, like, one thing to note here is that we mix and match a little bit, right? So some package we get from the OS package system, and some we get from the Python package system. And this is kind of what's it called? Personal preference almost. But one way to look at this is that if something is already packaged for the specific operating system that you're using, it's really good to kind of just grab that, right? Because now you don't have to wonder if it's installed correctly or anything like that. A lot of the testing has already been done against that specific operating system. But sometimes there are packages that are not packaged, right? Like, so this Cause package that we are interested in is not packaged for Ubuntu. So what we have to do in that case, we'll just do a pip install, right? And these are all, it's fine. Like if you wanted to do pip install numpy here instead as well, that's fine. That's just your personal preference, right? So that's these steps are in this post section, and that we will pretty much see that in all our build files. So again, I'm going to pause here for a second and ask if there are any questions here. We're going to talk more about this, but I just want to make sure that there's no questions at this point.
So when you're building this file, this is the stuff at the top of it. And this is for building the image.
Yeah, right. So this is the base system, or the base image, and this is the modification we want to make to that image.
Okay.
And let me see what the next slide is. Let me see. Yeah, so we can do this. This should work on any of our login hosts, login server 4 and login server 5. So I'm going to actually, can I copy and paste? Huh. Okay. Let's see. I should do this. We should. I'm going to exit out of this. I'm going to take this. Copy it. And no. All right, make it. So here I am on login server 4. So I have a container training directory, doesn't really matter. And my container, my container def. Right. So this is what we had. Again, we're bootstrapping a Docker image and with this. And there are other ways. You could start from another apptainer image and build on top of that. It doesn't have to be Docker here. But remember, I said they have a really good library of container images, whereas apptainer is a little bit more, you'll just find somebody's image somewhere else. They don't have that concept of that really good hub. So I would say a lot of the times we're just pulling from Docker. Doesn't matter. We just pull that image and it will become an apptainer image, and once we're done. All right. So this is the steps. we'll save this, and the build container here, like the build command, right, is apptainer, and it's one of these commands that has a bunch of subcommands. So we do apptainer build, and here's the image name we want, and here's the definition file, which is not spelled correctly. It's my container def. Right. So when I run this, a few steps will happen. So first thing that will happen is that we see it's copying these blobs. This is a Docker pull. So it's pulling down that image from the Docker hub, right? And then it'll do the unpacking, which is, reassembling that image. Come on. And now we see these are the commands. Actually, I did something wrong, but this is the command that we had earlier in the big build files. Let's see what we did wrong. What did we do wrong? Let me not copy this part. That's odd. I'll try one more time there. Get this at the same time. All right, here we go. Okay, so now it's updating. I must have done something bad when I copy and pasted this in here. Why is that? Yeah, we'll copy and paste again. I must have done something. Okay. Right, so that's what we want to see, right? So here's that second command. There's installing, and then the last one is pip install case, and so we get the log, and we get the image here at the end, right? We'll save that. I'll come back to exploring that in a second. All right, so slideshow. All right, so now we built our first container. And the other section I want to talk about is environment. But I also have a new example here, and we'll talk a little bit why that looks different. So again, we're doing Docker, right? But we know that we're going to do a conda. So we want to have something that maybe already has conda installed. If not, if we use the same base image here, maybe we use the Ubuntu 20, we would have to install conda, would have to configure it. But in this case, there's a perfect Anaconda image that we can just pull from. So we don't have to worry about how to set up this conda environment. All we have to do is assume it's there, do conda install, and CoPy, it's a different package, but the same idea. And the second thing we've added in here is this environment section. And this is a very common question that we have from our users is, now when I have my image, how do I modify the environment to work with that software, right? And so there's two answers. One is what I have here, where we can set the runtime environment. And it's important to understand that whatever you put in the environment is for the runtime, right? So build time is one thing, runtime later when you want to use it is a different environment. So that's why we put this export path in the environment section. And so the idea here is that we can build the container with these commands. Then when the when the image is done, when we run the container, we get this environment, right? So again, we're trying to start with a base image that is as close to what we need as possible. We do the steps that we need to do to make it ours and to make it, meet our requirements. And the last thing in this one is provide an environment for the user. So the second way to do this would be to have a wrapper around your job. And a lot of people do this as well, where they have, in their conjure submit file, they specify a wrapper that runs before or around their code. And then you can obviously modify the environment there as well. So that's the second way of doing that. Okay. Right. So any questions, other questions about building images? Okay. So the next step then is testing the container. And you all met with us when you get your OSG account. And one of the things that you might remember is that we always tell you to test stuff. Right? Test on a small scale, test things locally before submitting 1 million jobs and realizing that it's all broken. So the same thing goes with containers. And this is really neat because it is a really easy thing to do. But the idea here is that you build a container, you test the environment locally, you test it as part of the build, and then when your job starts up, you have good confidence in the environment. So the way to do this is with apptainer shell. So I told you before how apptainer has this subcommand. We used build before. Here we're using shell, and that will drop you into a container instance of that image. A few things to be aware of though. First is your home directory is automatically mounted. So that is your home directory on login 04, login 05 is automatically mounted in that container. Which is really convenient, but because it allows you to, access data and things like that via that mount. However, you have to be careful here with that maybe a home directory has extra stuff that affects your code somehow. I don't think so, but it could be. So just be aware that the home directory is mounted and sometimes it's a little bit of difficult logic to understand that you inside a container image, most of it looks like your custom stuff, but some of it, like home, is from the outside. And that's a very typical container model, right? That's part of containers, is to be able to bind directories from the host into the container itself. And it's just sometimes when you don't know that happens, that's a little bit weird. So remember, home is mounted automatically. And then as always, don't run any long or compute intensive jobs in the login nodes. Poking around, testing small jobs and things like that is fine. Don't run anything large and intensive on there. I should say the other thing that's really nice about containers, by the way, here is that the container we're talking about here, creating a container with apptainer or singularity, is portable not only within OSG, but also to, for example, your home institution, right? So if you're running some jobs in OSG and some of your campus cluster, you can take the container and the the ZIF file and move it to your campus cluster, and it will work there as well. So it's very convenient. The other thing to think about here, right, is I want to go back here for building the container for a second. So here, what we're seeing here is a recipe, right? This is the definition file. So this is a recipe for your environment. And let's say that you want to share, your environment with a colleague, or if you want to publish and say, here's how to reproduce my stuff, you have two options. One is that you can share this recipe, saying, here's how to build my image, or you can choose to share the ZIF file, the image itself. And a lot of people use that, like they publish stuff on Docker Hub, or they put on other image repositories, and that is, an easy way for them to have colleagues or students or something to say, if you want to run this, here's the environment that you need. The other thing that's kind of cool with apptainer is that you can also use it as part of a pipe. So if you use apptainer, you can just use it in a shell pipe where some stuff runs outside and some stuff inside the container. Anyway, so yeah, so this is an example of us exploring this image. So I'm going to switch again to my little terminal. And I have the image that I just built, so I can explore that with apptainer shell and the container image. And now I'm inside the image. Now I'm inside that container. And one thing to note here, and one thing that kind of people are getting confused about, is how is this different from, for example, a virtual machine? Because for both a virtual machine and a container is, it's an image of an operating system. So how is containers different, right? The big difference is that this doesn't boot up a whole environment. All we did is change the file system and the shared libraries and all that stuff, right? There was no booting of this image. You saw how quick that was, right? It dropped us right into it. But it didn't start any services or anything like that. It's just a shell around us that kind of provides that environment that we want. So to prove that, we can do Python. We'll start Python. We can import that library that we added, that pip installed Causa. So import Causa, and now we can use that. Causa. All right, oops. What did I do now? It's not say, it is cow. Okay, that's what it is. Cow, of course, Causa cow. Fine. So the point here is that we can test this environment, and we can, for example, see what happened if we were on the outside, right? If we were just on this machine, import Causa, right? It's not here. It's not available. So by being able to jump into that image, like we did with shell, Python 3, and import Causa, now we have that tool available to us with all the dependencies and everything. Okay. While we're in here, we can also look at PWD. I'm in my home directory. I have my stuff that I have from the outside. There's no, no difference from the outside and inside the container here. And we can show that by, for example, we can start a container. We can create a data file. So we can just create a little data file here. I want to do it in my home directory. So I go in the echo hello from the inside. I will create that to container data.txt, right? Okay, so now when I exit the container and I look in my home directory, there's the file that I just created from inside, right? So the fact that home is mounted is very very convenient. That's just what I did, right? I created a piece of data. I exited and the data was there. And that's all because home was mounted. Okay. When your job runs in Condor, it's almost the same thing. You don't have your home directory, but you have the same environment every time. So the last topic that we're going to talk about is how to use these containers in your jobs. And the first thing to think about is how do we distribute containers to the jobs? Remember how we had all those dots? We can go back all the way up to slide here. This one, right? So when we run containers and we have to ship the containers around to all these different places, it's the same thing with data, right? How do we ensure that we're doing an efficient job when we move this container around? The other thing that's interesting about containers is that there's a lot of reuse, right? If you're running 1 million jobs, all those containers, all those jobs are using the same container. The more we can cache and the closer we can cache that to those different sites will be helpful, right? So now I'm going to jump back in here, and the way that we do this is with the Open Science Data Federation, or STASH, and that is done in a few steps. We put your image under a protected username, and then you use this singularity attribute pointing to the path in Stash by this URL. And note that how part of this URL, right? So from here onward, protected user, like this is the same one as you have mounted on the login server 4. And as I said, cached, these images are heavily cached. And one thing that we have to be careful about here is if we want to update our image, how do we make sure that that image is not picked up from the cache versus picked up from our new version? And the way to avoid that is by versioning the file. So if you go back and see what we versioned file here, not here, sorry, in here, right? You see we created a file and it's called v1. So let me clear this up a little bit and I'll show you again. So the v1 here is just a versioning of the file. And that allows us to, when we make a change, right? Let's say we make a change to the container definition. Right? Doesn't really matter what we do. And then if I want to build that again, apptainer build, I would do my container v2, right? And then my container definition. So these versions are really important when you're using OSDF. So we can copy that into protected, right? Protected, my username, right? And once it's in here, I know what the URL is for Stash. So it's OSG connect. And then it is that path that I just used, right? So that is the image path that I need to use, right? Let me see. Yeah, so we talked about versioning. Once you put that in your Condor job definition, you don't have to worry about how to transfer this. This is all done by the infrastructure for you. It's also starts the image for you, everything. You just specify what image the job should use, and everything else is automatic. So we can then say, okay, what should the job look like? And we can create the job here. I'm going to exit out here again. And we're going to create this job. All right, so first we need some code to run. All right, so we're going to do my science.py. Right, and so in this case, it's just going to do what we did on command line for testing, import cowsay, and then cowsay cow hello world. We can change more that. And we can try it. Obviously, it doesn't work here because guess what? We can't. We don't have cowsay. We can do apptainer. I should run. I think my container. Science. All right, so it works inside the container and not outside. That's what we expected. And so now we have that. Now we want to create a job. And this is, just like with your regular jobs, the only addition is the singularity image part up here. I want to copy that. Create a job. And obviously the problem is here that now we have to change this to what we had up here, protected. Okay. Oh, and the other thing you have to be careful when you copy and paste from slides. See, like that's this fancy quotes that we need to get rid of. We need to have regular quotes in here. All right. So all we're saying is use this container to run this code. That's all we're doing. All right, and I'm going to submit that. It will take a few minutes to run. Because I'm not naming things correctly. That's the problem. All right, now we can submit. All right. So while we wait for that, questions? Everybody ready to build their own images? That's perfect. Okay, and visual is copying things. Okay, perfect. And we can see how this job is doing. Slide link, okay. And the queue. Another stuff in here. Oh, it's still running. It's still idling. Okay. All right. So we'll keep on talking and we'll come back to that job. But the point here is that running a job with an image is really just a one-line difference from running without it. Right. All we did is saying use this image. We didn't have to do any singularity commands or apptainer commands or anything like that. All we did was specify the image, and the infrastructure takes care of the rest. So let me go back into this mode here. That one, sorry. So let's talk about some best practices. And latest tag. This is something that was popularized by Docker, that you didn't have to version the images, you just use the latest all time. It's really bad idea to do that, especially like when you do science, right? Because now by using an image that is you're not specific about which one you're using, you're basically saying just you're taking away reproducibility here, right? Because like later on when you want to reproduce this, you can't, because you don't know exactly what image you used. So the point is, be specific with image versioning. When you do runs, use a specific version, right? The version number that we talked about here in images, it's important for OSDF to make sure that you don't get, the correctly image and not some old cached version. But the motivation here, right, is different. The one motivation is, yes, don't let the cache mess you up. But in this case here is, don't make it not reproducible by being lazy about versioning, right? Testing image in apptainer shell, that's what we've done, just did. And again, unique image names eliminates the risk of running a job with previous versions. So this is similar to 2, but the V1 or the versioning I use doesn't have to be yours, right? It just have to be a unique name. That's all that matters to OSDF. All right, so let's check on our job again, see if it's been running already. It has run. We have some log files here, right? So we have some outputs and errors. Let's look at errors, see if there's any errors. Nothing, perfect, right? Let's look at out, and there's a little cow. So all good, like it ran inside the right container, it ran the same right code, right? So that's perfect. Next step here, right? So again, the team here plus Andrew that we don't have an image for yet. We are happy to help you work on the images, working on making sure that not only that they run well on OSG, but that you know you are making smart choices about reproducibility and publishing and things like that. We can be reached by tickets, right? Support at osghcc.org. And another thing that's very popular for people and container questions, office hours. We run office hours twice a week, Tuesdays 3 to 4:30 Central Time, Thursdays 10:30 to noon Central Time. Make sure, by the way, that we have this Thursday we have canceled the office hours due to staffing. So this Thursday we cannot. There's no office hours. But other than that, twice a week. And the last thing is a feedback. So what we want to give you a chance to give feedback on this training. Rachel had posted it in the chat is a link to a Google form. It's very short. We just appreciate your feedback, and we can improve this training for future events. Okay, and I'm going to leave it there. I'm going to leave it with the feedback form up, and I'm ready for some more questions.